Hi, in this video, I will be showing you problem number 3 of chapter 9 section 1. Part A. For what values of r does a function y equal to e to the rx satisfy the differential equation 5y double prime plus 24y prime minus 5y equal to 0. Part B. If r1 and r2 are the values of r that you found in part A, show that every member of the family of functions y equal to a times e to the r1x plus b times e to the r2x is also a solution. As y is given as e to the rx, we will find out its first derivative and the second derivative. Y prime is r e to the rx, y double prime is r square e to the rx. It says in the problem that y equal to e to the rx satisfies this differential equation. So we have to plug in y double prime and y prime into the equation given in the problem. Let's call the equation as A1. So substitute y prime and y double prime into equation 1. So we get 5 times y double prime, so it's r squared e to the rx, then plus 24 times y prime, which is r e to the rx, minus 5 times y, which is e to the rx, 5 times e to the rx equal to 0. Here you notice e to the rx is common, that can be common factored out. So it is e to the rx times 5r square plus 24r minus 5 equal to 0. So e to the rx can never be equal to 0 because in its exponential function. So the only possibility is that 5r square plus 24r minus 5 equal to 0. So we can factor this, which is 5r minus 1 times r plus 5 equal to 0. This gives the two values for r. One is 1 over 5, the other one is negative 5. So the two values of r for part A are 1 over 5 and negative 5. The next part is asking us to show that every member of the family of the function y equal to a e to the r1x plus b e to the r2x is also a solution, where r1 and r2 are the values that we got from part A, which are 1 over 5 and r equal to negative 5. So we have to show, for part B, we'll consider r1 equal to 1 over 5 and r2 equal to negative 5. So we have to show that y equal to a e to the r1x, which is 1 over 5x, plus b e to the r2, negative 5x, is also a solution to 1. So for y equal to a times e to the 1 by 5x plus b times e to the negative 5x, let's find out y prime and y double prime. Y prime is 1 over 5a e to the 1 by 5x and then minus 5b times e to the negative 5x. So we are applying chain rule over here. Then y double prime, which is a derivative of the derivative. So we have to differentiate these two, which is 1 by 5a e to the 1 by 5x times 1 by 5. So we get 1 by 5 times 1 by 5. So that will give us 1 over 25. Then here that minus 5 will come out. So it is minus 5 times minus 5. That will be positive 25 b e to the negative 5x. So now we have to show this y satisfies the original differential equation given in the problem. So let's consider 5y double prime plus 24y prime minus 5y. We'll consider left hand side of equation 1. So we are actually considering left hand side of equation 1 for the new value of y. So it is 5 times, substitute the y double prime, which is 1 over 25 times a e to the 1 over 5x plus 25 times e to the 25 times b e to the negative 5x. That part is done. Then plus 24 times y prime. We got y prime here, which is 1 over 5a e to the 1 over 5x minus 5b e to the negative 5x. Then minus 5y, minus 5. Y is this expression over here. So that will be a times e to the 1 over 5x plus b e to the negative 5x. Now all we have to do is to distribute these values and simplify and check whether it turns out to be 0. If we distribute the 5, that will be 1 over 5a e to the 1 over 5x. Then 5 times 25, that will be 125. That will be 125b e to the negative 5x. Then here it's going to be, we're going to distribute the 24. 24 over 5 a e to the 1 over 5x. Then 24 times negative 5, that will be 120 b e to the negative 5x. Same way we'll distribute the 5 minus 5a e times e to the 1/5 of x negative 5b e to the negative 5x. So this is a big expression over here. So what we will do is to collect all the e to the 1 over 5x. We will collect all x to the 1 over 5x. So it is 1 over 5a inside, then 24 over 5a, then minus 5a. Same way we will collect all the e to the negative 5x. So we can write e to the negative 5x out, and then we will be left with 125b minus 120b minus 5b. So it is e to the 1 over 5x times. So if you simplify this part, it is going to be 0 plus e to the negative 5x. This part is again 0. So this adds up to 0. This tells us this new y that we got here is also a solution to the differential equation. This proves that y equal to a e to the 1 over 5x plus b e to the negative 5x is also a solution to the differential equation of 5y double prime plus 24 y prime minus 5y equal to 0. Hope this video helps.